So let's see the producer consumer problem. Producer and consumer problem is based on without busy waiting mechanism. So here you think that why I am calling this as a problem, not a solution, because the producer and consumer have some problem, although it is based on without busy waiting solution, and we will try to resolve this particular problem by using a concept called semaphore. Okay, so semaphore is a concept which will be used to resolve the producer and consumer problem. But before discussing the semaphore solution, let us try to understand what is the idea behind producer and consumer problem. Okay, so producer means the process who writes. Okay, so in computer science, generally whenever a process who write on some file or some other resources are called producer, and the process who read from the write process is generally called as consumer. Okay, so the process who write is known as producer, the process who read is known as consumer. Okay, so this is the particular algorithm, and this algorithm is based on the C programming language, because in GATE syllabus we have only one programming language, which is C programming language. That's why I write this algorithm based on C programming language. Okay, so in this particular algorithm, we have first defined a particular capital N as 100. Okay, and after that we will define the count variable as 0. So whenever count is referred, it means that the particular value 0 will be placed on that count variable. Though two functions are used, one is producer function and one is consumer function. Producer generally produce or write the item, and consumer generally consume or read the item. Producer will and consumer does not take any particular parameter. Okay, now after that, in this particular producer function, first we have defined a local variable item, and based on this while loop we are testing some conditions. The condition is item equal to produce item. So using this local variable, producer function will generally produce item continuously, and we already defined that the particular buffer capacity is 100. So here N is nothing but buffer, or the capacity of the particular memory where producer is generally producing the item. So item is equal to produce item. So producer continuously producing the item, and whenever it produces the item, it will generally store the local variable, and through the local variable we store this in the buffer. Okay, if count equal to n, generally at the initial phase count equal to 0, but when producer is continuously producing the item, then after some time this particular buffer is full. So we are generally checking the condition. If count equal to 1, that means buffer is now full, and producer no need to produce the item further. Okay, so at that point the particular producer, the process who writes the item, is now going to sleep. Okay, and before it is going to sleep, it is generally wake up the consumer, okay, who read the item. So insert item, and when it going to sleep, it generally each value of the particular item will be inserted. Okay, and then count is equal to count plus 1. So let's say we have a buffer of capacity 100 at the initial phase. Whenever process who producing one item, then it will insert the item in the particular n buffer variable, and then it will increment the count variable, and it will do things like that. After some time, this particular count is equal to n, which means the buffer capacity is full, and now producer is going to sleep. But before it is going to sleep, it will wake up the consumer. So how it will wake up the consumer? If count equal to 1 means whenever it will produce a single item, then it will wake up the consumer, so that the consumer who will consume the item after that. Okay, now let's see the function of consumer. void consumer void, it also does not take any parameters here. And in the consumer function we have declared a local variable item. So this particular variable and this particular variable are different because this is visible only in the producer function and this particular local variable is visible only in the consumer function. Got it? Now here also we will checking based on the while loop, we will testing some conditions. The conditions are if count equal to 0. So at the starting point, whenever producer does not produce any item, then the consumer will go to sleep. Okay, and if this particular condition is failed, that means there are some item which are present in the buffer. So consumer will now go to this particular memory locations and access this item one by one. So it will generally remove item from the buffer. Okay, this particular buffer. So item is equal to remove item, and then after at the same time whenever it will remove one item from the buffer or memory, it will decrement the count variable. So count is equal to count minus 1, and when it will going to wake up the producer whenever the count value is equal to n minus 1. So let's say consumer is continuously trying to consume the item or removing the item, and at that point let's say if count variable having value n minus 1, that means there are no item left in the buffer, and at that time particular consumer have the responsibility to wake up the producer. Okay, so if count is equal to n minus 1, wake up producer, and after that if this particular condition fail, that means our particular buffer is still having some item left, so consumer will generally consume the item. Okay, so in this producer and consumer problem there is a problem that whenever let's say if count is equal to 0, okay, if count is equal to 0 or if let's say here count equal to 1, let's say at that point producer is halted. Okay, producer, the process who have the responsibility to wake up the consumer, is halt at that place, then it will not generally wake up the consumer. And similarly here also if count equal to 0 at that place, let's say particular consumer does not sleep, because at that checking the condition itself it will halt it. So at that point whenever a producer, when the next time it will get a chance, it will continuously producing the item without worrying about the consumer who are not at sleep mode. Okay, so producer thinking that I am already waking up the consumer, and now the consumer have the responsibility to consume the item, and there is a particular here if you see that this particular condition leads to deadlock. So this problem, this producer consumer problem is having a major drawback, which is deadlock. Okay, and we are providing a solution to so that no deadlock will occur in the producer and consumer problem. So how we are going to provide a solution? If any producer is halt at that place, or if any consumer is halt at that place, then we are using a particular variable mechanism or technique called a bit, which are called as semaphore. So this bit is called semaphore, and it continuously monitor the sleep and wake up call of producer and consumer. So semaphore is a variable which continuously monitor the sleep and wake up call of producer, sleep and wake up call of producer and consumer. So whenever a process, let's say here producer halt at that place, then the particular bit which we are using to wake up the consumer is not at used, and when the next time this process get a chance, producer get a chance, then it will use that particular bit to wake up the consumer, so that consumer properly use the consume the item and there will be no deadlock occur in that particular problem. So in the next video we will see what is a semaphore and how semaphore will provide the particular possibility that so that no deadlock will occur in the synchronization mechanism solution without busy waiting technique. Okay.